Hi, I'm Darren and welcome to Level Up EE Lab. Well, I'm back to working on the Heathkit HW-101 project, and that means I needed to fix the power supply. Let's check it out. Picking right up from where I left off in episode number 2, my next step is to replace the caps, resistors, and rectifiers in the HP-23 power supply. After all, I can't troubleshoot the HW-101 until I have a source of power for it. I decided to strip it completely down to a bare chassis. Now, most of these parts are going in the trash anyway, and starting from an empty box will make the mods and the reassembly a lot easier. I'll also repaint the power transformer. It has a lot of rust on the outside edges of the laminations, and hopefully it hasn't started progressing inside the stack. And speaking of tossing parts, that means all the electrolytic capacitors, including these 4 big boys. Now, I know some guys will take the time to restuff them or just leave them on the chassis and then bypass them with new ones underneath so that the look of the old power supply is preserved. And I've done exactly that on some of my other restorations. But in this case, the paper outer casings have soaked up a lot of that smoke residue, and there's no practical way to clean them. So in the trash they go, and I'll put my custom printed circuit board in their spot. Here's my design for the rectification circuit. It's functionally the same as the Heathkit design. Both the 820 volt and 350 volt sections are voltage doublers, and the negative DC bias section is a simple half-wave rectifier. And here's the 3D model of the layout. Overall size is 80 by 112 millimeters, and that'll fit neatly between the transformer and the choke. Man, these modern equivalents of the electrolytic capacitors sure are ridiculously smaller than the originals. The other parts on the board are the bleeder resistors and diodes. I'm showing quite a few bleeder resistors, more on that later. KiCad version 6.0 now has the ability to generate hatched ground planes, so I decided to give that a try. I don't really need it hatched for this application, but for this experiment it did turn out nice, only a few tiny bits of toner didn't adhere. Here it is after a dip in my homemade tin plating solution. And here it is all populated. The caps are all Rubicons, and they've got equivalent to slightly higher voltage ratings than the originals. Note that I set all the bleeder resistors and diodes several millimeters off the board for better air circulation. Only half of the bleeder resistor spots are populated, and again, I'll explain why later. Now, because I used a single-sided board and with the components on the top surface, that means the copper side is on the bottom and it's not easily accessible for soldering wires to it after it's installed. So I'll have to solder the wires before installing the board. I'll just make them long and then trim them to length afterwards. For this portion of the reassembly, I followed the steps in the Heathkit assembly manual, starting with installing the socket connector. And boy, this thing is not easy to install. There's a spring clip that retains it on the inside of the chassis, and getting it in place was definitely tricky. I did not want to accidentally overstress it. After that comes the choke and the transformer, which are pretty easy. I mentioned earlier that I repainted the transformer, and here's how it turned out. I sanded off as much of the rust that I could, then used self-etching primer followed by a matte black top coat. I think it turned out pretty sharp. Here's where I am so far in the repair and rebuild of the power supply. I've got all of the primary side of the AC done. I thought I'd take a moment just to describe some of the changes I made here. So first and foremost, I did go with a modern 3-prong cord and put in a socket for that. And the original design, so the schematic here, had 2 4-amp fuses, one on each prong of the cord, because of course the old style cord wasn't polarized, there was no third prong there, so you could plug it in either way. Heathkit decided to put a fuse in both leads. I've replaced that with just a single fuse on the hot side because now this is properly polarized, and I have of course a very short connection to the fuse, so in case something goes wrong and the fuse blows, there's only a very small portion of the power supply that's going to have live AC on it. Off of that, it's going over to the stock power switch. Now, this thing is kind of redundant because the very next thing that is connected here is, of course, the on-off switch on the HW-101. That's on pins 9 and 10 on the power supply connector here. So Once you turn the switch on the HW-101, the power comes back, and then we'll go into one of the two primary leads on the transformer, and then of course the other lead on the primary is going to neutral, and then that completes the whole AC side. Another thing that I did, and I like to do this on just about every old AC power piece of equipment, is put in some filter caps. These are 1 nanofarad. I suppose 10 nanofarad might work just as well, but 1 is what I happen to have on hand. And of course, these are safety caps. These are the ones that are rated to go on the AC line side from either the hot to neutral or the neutral to ground. In this case, they're both going to ground. And I don't know if that's going to make a big difference or not, but I don't also think it could hurt to have those in there, just some additional filtering. So, and the last thing, of course, I did retain the original pilot lamp. That will come on whenever the power is on here and the power is on the control on the HW-101. And that completes the primary side wiring. So next to do is to hook up everything on the secondary side. All right, now jumping ahead in time, I have finished all the chassis wiring on the power supply. Let me walk through it briefly before I flip it over and we take a look at the other side. I did end up adding a couple of terminal tie bar strips here, mostly because the wires coming out of the transformer are just too short to reach all the points on the circuit board. And I wanted to space things out a little bit more, give a little more room to route the wiring in. And I did put a little bit of extra slack in most of these wires. I didn't run them very tight, and I'm certainly not bundling them, trying to go for extreme neatness here. I want the slack in case I do have to remove the mounting for the circuit board and drop it down a bit to do some rework or whatever, so that there's enough slack to be able to do that. And you can kind of see over here on the adjustable bias, these actually are 2 watt resistors, believe it or not. And I'll comment on those when I talk about the bleeder resistors on the other side. Quite a bit smaller than traditional 2 watt carbon composition resistors. But I'm happy with how this turned out. Like I say, I didn't go for ultra neatness. I just tried to make a little extra slack in here so I can have some extra wiggle room in case I need to rework it in the future. So with that, let me flip it over and let's take a look at the top side. And here's what it looks like flipped right side up. The board fits neatly in between the power transformer and the choke. Now, if this was out in the open, I definitely would have to put some sort of cover over this, because a lot of the exposed metal here on the diodes and the resistors is going to be at high voltage potential, and that's a hazard. But this is going to be stuffed inside of the speaker cabinet, and I'm not too worried about it for what I'm going to use it for. But nonetheless, those are exposed. Now, I did comment earlier briefly about these resistors. These are actually 2 watt flame-proof metal film resistors, and I'm a little nervous about how hot those are going to run. Now, I do know that modern metal film resistors are definitely more stable at higher temperatures, but nonetheless, just doing a quick comparison, this is an original size carbon composition 2 watt resistor, so quite a bit bigger. The mechanical engineer in me makes it pretty obvious by inspection that this guy has a lot more surface area than that guy. So for a equivalent amount of power going through there, this guy is going to run cooler with natural convection than this guy. So we'll see what happens. And just for additional comparison, here's an old carbon composition 1 watt resistor and a carbon composition half watt resistor, and it's about the same size. And I'm kind of jamming it in here, but the little old half watt, it's almost identical in size to the 2 watt metal film. So one thing I did provide in the circuit board, you can see some additional holes here. These 4 resistors are the 100K bleeder resistors for the high voltage section, and what I'm having here is for plan B. If these run too hot, I can take out these 100K. There's 2 of them here in series, and then another 2 in series over here. I can take these out and put in 8 200K resistors instead of the 4 100K, and get the same effective resistance and cut in half the load on each resistor. So if these run too hot, I can swap that out. Now these over here are for the medium voltage circuit, and I'm not too worried about those. Those are going to be running at much less total power dissipation, but nonetheless, we'll see when I power it up. And that leads into the next item to do is get this connected to my dim bulb tester, hook up my meters, and check it out. Okay, I've got the power supply set up with my dim bulb tester, which I've used on several other episodes and Level Up EE Lab, so I'm not going to go through the explanation again here, just with one comment. I'm going to watch for that light bulb, make sure it doesn't glow brightly when I start the test. So I've also got 2 meters hooked up, 2 DC meters hooked up, I should say. First is my Keithley. It's connected to the high voltage output. And I've got my basic DMM here connected to the medium voltage output. So those two, when I get to full line voltage, should read about 800 volts, give or take, on the high voltage side, and about 300 volts on the medium voltage side. So that's what I'll be looking for. And then after I crank it up slowly and see that everything's fine, if I reach those voltages, what I'm going to do then is reconfigure the input of the DMM here to look at the negative bias and see where it is, and then swap the ground connection, because right now the ground is connected to the common for the DC circuit, and I have to swap the ground, or the common rather, for the DMM to the filament common in order to be able to measure the filament, and have to switch it to AC mode. So here we go. Let me turn on the power.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
And I'll start cranking up the voltage here. And again, watching for that bulb, make sure it doesn't start glowing brightly. And then of course, watch these voltages come up slowly as I turn up the AC slowly. And pausing around 60 volts here, about halfway up. Seeing I got just around 400 volts on the high voltage side and about 180 on the medium voltage side. And no magic smoke, always a good thing. And the bulb is not glowing, so I'll keep going. And I'll just stop it there around 115 and see where we are. So got about 720 volts on the high voltage, 323-ish on the medium voltage. That looks good. And it may not come up on the camera, but there is a very slight glow in the bulb, and that's fine, just to have a little bit of power being drawn by the transformer without a load on either of those two circuits. So that looks pretty good. I think that should be a little higher, though. I'm not sure why it would be a little bit low, but I think that's still within the range of what the HW-101 wants. So let me reconfigure the meter here and see what our negative bias looks like. Negative 117 volts should be around negative 130, so that's a little low as well. Again, not sure why, but not that far off. Now let me reconfigure the meter here, and I have to swap out the probe here, so let me do that and we'll check the filament voltages. Okay, I've reconfigured the multimeter, and the reason I needed to do that, if you look on the schematic for the secondary side, hopefully this comes through on camera, the filament supply has its own common that goes over to pin 2 on the output plug, and that's what I've got the ground connected to, the ground, or common I should say, of the multimeter. That's independent of the chassis ground, so that has to be connected up directly. You can't just connect it to the chassis ground if you're going to measure the filament voltage. And of course I changed the meter to AC setting, so let's see what we got on the 12 volt side. Okay, about 13 volts, that's good. And then on the 6 volt side, about 6.5, so looking good. So I'm pleased. This guy turned out to be fairly simple to repair. It's working well, and the next thing to do is button up the bottom cover and get it ready to install back into the speaker cabinet. There's also the adjustable bias function, and here's a quick demo of it working. This is something you would adjust after you've connected the power supply to a transmitter, and then use it to set the idle current for the RF power tubes. Also, there's the power on indicator, and yes, it's working fine. So that leaves just buttoning up the chassis by reinstalling the bottom cover. Now, because this supply installs inside the speaker cabinet, there's 4 protruding bolts on the cover that'll poke through the floor of the cabinet and be secured with nuts and washers. But until then, those bolts would definitely scratch up anything that the power supply is sitting on. So for now, I've just added some brass standoffs to them. Here it is, all done and ready for action. I'm still amazed by just how much smaller those high voltage caps are, and just for a sense of scale, here's the originals. Now, one other thing that I could have done here is repaint the chassis. The original paint's not in the best of shape, and there are several areas where it's peeled or chipped. But doing so, of course, would obliterate the pinout legend and all of the other text, and I really didn't want to lose that bit of detail. So it's a trade-off. The text remains and the chips and flakes just add a bit of character. Alrighty, I have a functional power supply now, which means once I finish replacing the bad resistors and caps on the HW-101, I've got something to power it up with. And speaking of those, I just today received the replacement resistors and caps, so I've got the parts I need to begin that phase of the project, which will be the subject for the next video. So I do hope you're enjoying this series, and thanks very much for watching, and until next time, bye for now.